Next, we will discuss constant volume process, or it is isochoric process, right? This is an isochoric process. So how will you show that in a PV diagram? Initial state was 1. This is the PV diagram, that is pressure volume diagram. So initial state was at 1. So initially its pressure was P1. Now it moves to state 2. Moves to stage 2. Its pressure is P2. Now its pressure becomes P2. That means, so this is how you show a constant volume process in a PV diagram. Here you can see that volume remains constant throughout. There is no change in volume. So what will be work done in this process? So W12 is equal to integral PdV. This is the expression, general expression you are going to use. So integral 1 to 2 PdV. But in here you can see that dV is 0. There is no change in volume. So W12 is actually 0. So work done in an isochoric process or a constant volume process will be 0. This is evident from this figure because area under this process or this line will give you the work. You can see that there is no area enclosed under this line because this is a vertical line. So there is no area enclosed. So work will be 0. Now, what is the expression for change in internal energy? That is delta U. See, this expression we have studied in the specific heat section. Okay, so delta U is given by m into Cv into T2 minus 1. This is the specific heat at constant volume, Cv, and this is mass of the gas. And T2 minus T1 is the change in temperature, T2 and T1. And you know that Q, when you supply heat to a process, part of it will be used for raising the internal energy, and part of it will be used to do work. So Q is equal to delta U is equal to mCv T2 minus T1. Okay, so mCv T2 minus T1. So this is the expression for heat here. Change in expression for delta U is here, and W12 it is 0. So Q is equal to delta U is equal to mCv T2 minus T1. So this is all about isochoric process. The important point in isochoric process we need to remember is that the work done is 0.